Hello everybody, my name's Bob Misen. Very glad to be showing you a little video about 8 great astronomers, people who have told us an awful lot about the universe that we live in. We're going to talk about people who have taken sketches, drawings of hundreds of distant galaxies and star clusters, and we're talking about the 18th century here, a couple of hundred years ago. We're going to talk about people who measured the distances of objects in our universe and told us exactly how big it is. Also, what are stars made of? Somebody found that out early in the 20th century. How do they work? What makes a star shine? And who found out that most of the water in our bodies was delivered to planet Earth by comets and asteroids billions of years ago? It's a very fascinating story. Here we go. 8 great astronomers, just like this woman here, from ancient times to 2020. This is Hypatia. As you can see from the top there, she lived a couple of thousand years ago. She was a mathematician. She looked at the sky. She thought about the ideas of the time. And although she's usually considered a Greek person, she lived in Egypt, which was then part of the Roman Empire. A bit complicated, isn't it? In Alexandria in Egypt at the time, there was a big sort of university called the Neoplatonic School. And there she taught philosophy and astronomy. Her father was one of the professors at the school. Hypatia invented the improved astrolabe. Now there's a picture of one at the bottom. What's an astrolabe? It's a thing that you look at to work out what might be in the sky at that time of the year. It might tell you things like when the next eclipse is, or what constellations you can see, the phases of the moon. Will it be a full moon or a half moon? And this was based on something called the Antikythera mechanism, which was found in a sunken ship. It was a sort of metal machine that calculated what's going to happen in the night sky. A fascinating thing. And if you ever go to Athens, you can see it in the big, I think it's called the Archaeological Museum in Athens, together with lots of other stuff that was found in this ship, including a beautiful statue of a horse. Hypatia read Ptolemy's Almagest. Now, Ptolemy was a Greek astronomer, and he wrote a big book called the Almagest, and it simply said, what can you see in the sky? And there's a sort of modern copy of it there, you can see at the bottom, lots and lots of lists about what you can see in the sky. And she brought it up to date for the year 350, as you can see there. That's her father, Theon. And here's Hypatia. And very soon she became more famous than her father, who was a tremendously well-known professor at the university. Sad to say, a lot of people in Egypt were very jealous of Hypatia because she was such a well-known and famous person. And in a battle in the streets between the Romans, who owned the place at the time, it was part of the Roman Empire, and the followers of the Christian bishop Cyril, she was involved in all this fighting in the street. And the story goes that she died under the wheels of a passing chariot. Or was she pushed under the wheels of a passing chariot? Nobody really knows how she really died, but she certainly was one of the greatest women astronomers that ever lived, and most people have never heard of her. There was a film about her in 2009 in Spanish. If you speak Spanish, you might be able to find it on the internet. And she had an asteroid named after her. There are millions of asteroids up there in space going around the sun, and one of them is called Hypatia. Did you know that nearly all asteroids are named after women? It's a fascinating fact, isn't it? Here's my second famous astronomer. This is Caroline Herschel. She was German. Her real name was Carolina Lucretia Herschel. And as you can see, she was born in 1750. She died in 1848. She was the first professional female scientist, the first scientist who worked for a living as an astronomer. And she was also the first woman ever to discover a comet. The picture below shows Caroline and her brother William discovering the planet Uranus in 1781. Now, you might think that this was done in Germany because she and he were both Germans, but when brother William came to England as part of a military band, because he was also a musician, he decided he rather liked the place. And he came back a few times and decided, I think I'll live here. And so he lived in Bath, a beautiful city in Somerset. And after a while, he asked his sister Caroline to come and live in the same house. And they worked together in that garden on astronomy. You can see William's big telescope there, and they both used it. He discovered the planet Uranus. She discovered lots of comets and galaxies and things like this. And that was in the 18th century. And if you want to go and visit that garden where they're sitting, that's easy. You go to Bath, M4, junction 18, I think, and you go to the 19 New King Street, the William Herschel Museum, and you can see all the work that they did. You can see a copy of their telescope. It's a very beautiful museum. It's got a little cinema underneath it too. 19 New King Street, Bath. Here's one of the first things she discovered. This is a star cluster. Stars are born in large groups, and they gradually find their way out and become other stars in space. But this is a cluster called NGC 2360. And although it's not a very exciting name, it's an exciting object because it's the first thing discovered by Caroline in her long, long work as an astronomer. Here are some other things that she found. This little galaxy here, M110. This is the enormous Andromeda galaxy. It's the furthest thing you can see with your naked eye. If you go to a really dark place and look in the constellation of Andromeda, you can see this tiny blur of light. And that light from this galaxy and its two little neighbor galaxies here has been traveling towards you for more than 2 million years, longer than the whole history of the human race. Some other things that she discovered. Of course, she wouldn't have seen them like this in her telescope. They would have been little fuzzy blobs in space. Star clusters, a whole list of interesting objects. Here's a very interesting thing that Caroline Herschel discovered. It's called the High Cluster. Why is it called that? Well, there aren't many things in space that talk to you, but if you join up these stars like that, it says hi. See it? You need a telescope to do this, but it's an interesting little object, isn't it? This is another one that she discovered. Has the not tremendously interesting name of NGC 6633. It's in the constellation of Ophiuchus, the serpent carrier. And here's a sketch that I did back in 1987 of Comet Bradfield, discovered by a man called Bradfield in Australia. And here's the comet with its fuzzy head and rather scruffy looking tail. And here's the cluster that we've just looked at, NGC 6633. And the comet appears to be passing through it, although of course the comet's much nearer because it's in our solar system. William and his sister Caroline began a 20-year survey of the night sky from that house in Bath, and they found thousands of new objects working together. And a lot of astronomers work using the New General Catalogue, and their list was the sort of basis, the backbone of this catalogue, which was published in 1888. And there's the telescope that Herschel used to make many of his discoveries. These are the comets that Caroline Herschel discovered. Remember, she was the first woman scientist ever to discover a comet. She's got a crater on the moon named after her. A lot of craters on the moon are named after famous scientists. And there it is, that little crater there. And like Hypatia, she's got an asteroid named after her too. It's not called Caroline, it's called Lucretia, which was her middle name. And it belongs to the Flora family of asteroids, which all sort of go around the sun together. Discovered in 1888. How big is it? 12 kilometers across. Not very big for an asteroid, but you wouldn't like to have that in your way when you travel through space. Here's the tombstone of Caroline Herschel, and on it it says, "The eyes of her who is glorified here below turned to the starry heavens." So one of the greatest women astronomers of all time. My next astronomer is Annie Cannon, who passed away in 1941. And this is a little clue at the bottom for the contribution that she made to our knowledge of the stars. She looked at all sorts of different stars using an instrument called a spectroscope. A spectroscope shows you basically what things are made of. If they're glowing, if you point a spectroscope at a candle burning, it will show you what it's made of: carbon, oxygen, whatever. If you point it at a light bulb, LED or an old style light bulb, it will tell you the kind of light that's coming from it and all the different chemical elements that are burning inside those bulbs. And here's her classification. She found that stars have all sorts of different types of light coming out of them. She was born in 1863 in the USA, and she studied physics and astronomy at Radcliffe College, which was a famous women's university at the time. And then she went to work for Harvard Observatory, which you can see a picture of it below, one of the most famous observatories in the USA. There weren't many in the 19th century. She earned 50 cents an hour. I suppose it wasn't too bad in those days. And they looked at different kinds of stars from these domes here. Everyone contains a telescope. So, as I said, she found out what kind of light came from stars and divided them into 7 main types: how hot those stars were, what sort of gases burning inside them. And in her time at that observatory, she looked at 225,000 different stars. That's a lot of stars. Eventually, she was put in charge of all the photo work at Harvard Observatory, and also discovered some variable stars, stars that change their brightness over time, and 5 novae. A nova is simply a star that suddenly flares up to become much brighter than it was. She got awards not just from American universities, but also from the University of Oxford in England too. And the Henry Draper Gold Medal, which is given to some of the best scientists in the USA. You've guessed it, she's got a crater on the moon named after her, and an asteroid which is called Cannonia, not Cannon. So that's Annie Cannon. Our next astronomer is also an American, and as you can see from my slide, she was a computer, because the word computer hasn't always meant a machine that you can use for writing your texts and sending your emails and whatever. In those days, a computer was a person who did computing, a person who did mathematics, sums, if you like. And a lot of women were employed at the observatories in America to write down all the data from the observations that were done with the big telescopes. And while she was working on data, Henrietta Leavitt found something very strange. She was looking at the observations of a star called Delta Cephei. in the constellation of Cepheus, who was one of the ancient kings in Greek legends. And she noticed something strange about Delta Cephei. It varied. It got brighter fairly suddenly, and then slowly it would fade away again. And it kept doing this over and over and over and over again, exactly the same pattern of brightening and dimming. So that special kind of star that she discovered, changing its brightness all the time in exactly sort of the same way, let her work out that you can use these stars to work out the distance of things. She was the first astronomer to give us a tool for working out the distances of distant objects. So if you find one of these in the Andromeda galaxy, you can work out how far away it is. And she did. And she thought that the galaxy was over 1 million light years away, which is right. I mean, nowadays we have much cleverer instruments and we can measure it almost exactly. It's 2.5 million light years away. So here's that galaxy we were talking about before. That light has been traveling towards the camera for more than 2 million years, the whole history of the human race. She too has, an asteroid and a crater on the moon named after her. And she was also rather deaf. And deaf astronomers can look to Henrietta Leavitt as one of the most famous women astronomers of all time. Cecilia Payne-Gaposchkin, as you can see, a fairly recent astronomer, passed away in 1979. And she was one of the astronomers who told us what the universe is made of. What's the sun made of? What's the earth made of? What are we made of? Well, we know that the earth, the sun, we are made of all sorts of different chemical elements, more than 100 of them. We hear about these all the time. I mean, iron, copper, oxygen, nitrogen, hydrogen, all these 100 different elements that make up all the different things that we can see around us and we can see up there in space. And Cecilia Payne-Gaposchkin worked on the spectroscope, again, that element that shows you what something is made of, if it's burning or glowing. And one of the most famous things she said was that the reward of the young scientist, and I hope some of us will become scientists as we get older, the reward is the thrill of being the first person in the history of the world to see something or understand something. And nothing can compare with that experience. She was born in Wendover in Buckinghamshire, 1900. And she went to Cambridge University and to that Radcliffe College in America. And one of the most famous books in astronomy is Stellar Atmospheres, talking about the gases that stars are made of. And she worked out how stars make the different elements that we see all around us, the atoms that we're all made of. Did you know that you are a big chunk of stardust? Let's talk about what we're made of. Our blood is red. Why? Because there's iron in it. Our teeth and bones are very hard. Why? Because they're made of calcium. And that can be a very hard substance. Most of our body is water. You may know that water is hydrogen and oxygen. Hydrogen was made in the Big Bang that started the universe billions of years ago. Oxygen is made inside stars. Everything else is made inside stars. Copper, nitrogen, aluminium. Find an element and it's made inside a star. And so all the little atoms that make up human beings and trees and horses and books, and I'm looking around the room here, ceilings, walls, light bulbs, my scarf, my pills, my clock, they're all made of stardust, things made inside stars, little atoms. Yes, she's got an asteroid named after her. This is asteroid Payne-Gaposchkin. There it is. Here's Caroline Shoemaker. Shoemaker is a famous name in astronomy. She was married to Eugene Shoemaker. Between them, they found asteroids, they looked at comets, they discovered comets, and they also toured the world looking for meteorite craters, big holes made by things falling down from space. You may have heard of the Arizona crater. They did a lot of work there. And there's one in Australia. Well, there's lots in Australia, in fact. And the Shoemakers visited them. She didn't start astronomy until she was 51 years old. That was when she married Eugene Shoemaker, her husband, and they worked together on all these different things. And between them, they discovered lots of comets. Here's a comet. It's got a big head with gases coming out of it and a tail streaming away from the sun, which must be down here somewhere. One of the first scientists to suggest that most of the water on planet Earth came here billions of years ago from comets and asteroids that crashed into it. The Earth is about 4.5 billion years old. A billion is 1,000 times a million. All the water is thought to have come from space. And that's what we're mostly made of. And if you stand on the beach and look out into the sea, all that water came from space. The water from your tap and the rain that we've had recently. It's all comet water. Interesting. Jocelyn Bell is a very well-known astronomer. She's still with us, and she's famous for her discovery of pulsars. You might guess that that's a star that pulses. It sort of goes click, 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 click when you listen to it with a radio telescope. If you look at it with an ordinary telescope, all you see is a tiny dot. But the one that Jocelyn Bell discovered way back in the 1960s was a radio pulsar. So you need something called a radio telescope to look at it. Anthony Hewish, Martin Ryle, Jocelyn Bell all worked together on this project. In 1967, while Jocelyn was looking at miles, kilometers, if you like, of printouts from this giant radio telescope in England, she noticed that something kept making a repeated pattern of noises. And this sort of sound, she called it scruff. What were these little repeating noises over and over again? Beep, 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 beep. They thought, first of all, it might be satellites orbiting the Earth, because in 1967, there were a lot of satellites up there. No, not that. Television signals from France? No. They checked all the airports? No, it wasn't the radar. And so, as a bit of a joke, they called these little beeps little green men. Little aliens, perhaps, going beep, beep, beep up there in space. But finally, of course, they worked out with optical telescopes, the ones that you look through, that there was a little star in the middle of the Crab Nebula, which is the remains of a supernova, a star that blew up thousands of years ago. And that little thing was shining, and it was making this little repeated signal. So the first pulsar, and pulsars can tell us a lot about how stars work. Why did that star blow up? And there it is. And you can see here the sort of ripples of the solar wind, if you like, the same thing that comes out of the sun as the star blasts its body out into space. And when it does that, it makes lots of radio noises too. My last astronomer is Beth Brown, a 20th century astronomer, but she certainly lived, as you can see, into the 21st. And She was one of the people who worked on the X-ray astronomy that is now a very important part of the whole science. Here's an X-ray object. This is Tycho's star in the constellation of Cassiopeia, the beautiful queen of Ethiopia thousands of years ago. And this star gives out a lot of noise. You can't just see it with telescopes. You can see it with X-ray detectors as well. Up there in space, there are several satellites that look at X-rays. X-rays are rather dangerous things. Have you ever noticed why the dentist walks out of the room when she does your X-ray and comes back again afterwards? Now, a little bit of X-rays won't hurt you if you have them passing through your teeth. But if you were sitting in that room all day, it would be quite dangerous, because X-rays are sort of rather energetic little waves, and they can break things up. So you don't want to be sitting in front of them all day, and neither does the dentist. Beth Brown was a great educator in astronomy. She was one of these people like, you might have heard of Patrick Moore in England and Professor Brian Cox nowadays. And these are people who try to get people interested in astronomy. She was the first African-American woman to get a PhD, a Doctor of Philosophy degree from the University of Michigan. And as I said, most of her work was on X-rays from the satellite called ROSAT, Röntgen Satellite, that stands for. Röntgen was a German scientist who discovered X-rays about 19th century, I think that was. So one of the things that Beth Brown found out was that it's not just light and radio that comes out of stars, it's X-rays too. And a lot of people have been working on X-rays, and they still are. You may have heard of NASA, the American Space Agency. How do they get those spacecraft to Pluto, for example? A spacecraft called New Horizons went to Pluto a few years ago, and it got there at the right time, in the right place. How do they do that? It's millions and millions of kilometers away. And it's engineers and scientists like Beth Brown who made sure that those satellites went in the right direction, and they calculated exactly how fast they'd have to go in order to get to the right place. Aren't people clever? Beth gave planetarium shows showing people all the different constellations of stars in the sky, these patterns that people made thousands of years ago. And she told everybody about NASA science and all the different things that they discovered. And her public astronomy course, you can still find this on the internet, I think. It's one of the most popular things that people look at on the NASA website. Did I say she was the last one on my list? I was lying, actually, because I've just shoved in a surprise number 9 astronomer. And she was not this guy. No, that's Asaph Hall, who discovered the 2 moons of Mars in 1877. His wife, that's my last astronomer. She wasn't really a scientist, but she said to Asaph Hall, who was looking for these things through a telescope and didn't find them, she said, get out there and find them. Come on, keep going. Be patient. Don't give up. And Asaph Hall, who discovered the moons of Mars, wrote, I might have abandoned the search if it hadn't been for the encouragement of my wife. And there she is. This is Angeline Stickney Hall. And for her role in finding those satellites of Mars, those 2 little moons, they named 2 craters on one of those moons. This is Phobos, one of the moons of Mars, and both these craters are named after her, Angelina Stickney Hall. Phobos is a weird satellite. As it goes round Mars, it gets closer to it all the time, not like our moon, which is getting a little bit further away from us all the time. And in 50 million years, you won't see it, in 50 million years, it'll collide with the planet or be broken up completely. Poor old Phobos. There's a point to make here, isn't there? Even in the modern age, there have been battles to allow females to study sciences. This is what Kerry Scullion, she works at the Armagh Planetarium in Ireland. Battles to allow females to study sciences. But of course, nowadays, this doesn't happen. It's taught us that despite the many hurdles that can face us, anything's possible. Both male and female astronomers have made massive contributions to science, and we mustn't forget those contributions. That's the end of my PowerPoint. Thank you very much. Keep looking upwards, and if your sky is full of light pollution, ask the local council why this is happening. Why aren't they pointing their lights in the right direction? Thank you very much.